All right. I thought I would try this out a little early just to see if the video and the audio and all that stuff is working. YouTube tells me there are already people in here. If you happen to be, would you mind just saying something in the chat and let me know if you can like hear me, see my screen, etc., etc. If you're shy, that's okay. We'll get started for real in 5 minutes, but I just wanted to make sure like stuff is working. La la la. Oh no, now the sound of my voice has scared people away. Let's give this a try. Okay, awesome. Cool. Well, this is very exciting. This is the first time I've ever done this. I was inspired by Ian, my boss at Hypar, who's just started doing this like kind of live streams of like live coding for Hypar, and I might try and do some of those myself, but I thought it would be fun to start with something a little less work-oriented, a little more fun-oriented. Yeah, that's what this is going to be. It's very improvisational. I truly have like no idea what I'm going to do. So we're gonna have fun together, and I hope too that this will be like interactive. So like, please, I'll be monitoring the chat. If you have ideas or questions or whatever over the course of the whole thing, like please feel free to speak up. It seems to me that there is a little bit of a lag with the chat and with just like the timing and the audio and stuff. So it may take me a minute to, or rather, you hear everything that I say about like, I don't know, 30 seconds or later than I actually say it. So there may be kind of like a lag or a delay, but we'll figure it out. I am gonna go on Twitter and just make one more announcement that we are currently live, and then give folks another minute or two to join us, and then we'll dive in. All right. Yeah, I've been trying really hard to avoid the temptation to like plan what I was gonna do, because I think it's much more fun to like actually watch someone work through ideas live, and it's no fun if it's kind of like a canned example. So I've been trying to like be very zen and keep my like mind empty, and we'll just figure something out from scratch. Now, the flip side of that, of course, is that it could be a total disaster, and we could manage to make nothing particularly interesting. And that happens with some frequency when I'm like using Grasshopper creatively. Is that I'll noodle and doodle and play around with stuff, and then I won't be happy with any of the results. And so there's a reasonable chance that that will happen here too. But I am gonna try to kind of explain what I'm doing and my thought process as I go along. I suspect that like there will be, if nothing else, some opportunities to learn some interesting Grasshopper techniques. I'm kind of a weirdo. I think I use Grasshopper differently than most other people. But also, I think there are kind of like useful tips and techniques that will come up that are actually super practical for, you know, using Grasshopper for work purposes or whatever else. So it's going to be an interesting mixture of, you know, kind of like creative and improvisational and messy Grasshopper, and potentially also some like power user pro tips of just, you know, stuff that I like to do when I'm building a definition. So it is now noon, so I think I'm gonna dive in and we're just gonna launch Grasshopper. Now, there's nothing quite as terrifying as the like empty Grasshopper canvas. And so when it comes to like starting a piece, you know, sometimes I have an idea in mind or something that I want to play with or some concept, or more often than not, it's actually like something that I saw somewhere else that I want to imitate or mimic. So oftentimes I'll spend some time on Pinterest or on my like Instagram feed and find stuff that looks cool to me and that I want to mimic or imitate. I think that like one of the things that's interesting about trying to like reverse engineer something that someone else has done with Grasshopper is that inevitably when you're done, the thing that even if you manage to reproduce what you were starting with or what you were trying to imitate perfectly, you just tweak the sliders and all of a sudden you have different work. So I think it's always an interesting exercise to kind of like extract a parametric model, something that's like dynamic and flexible, out of someone else's work. So you're actually gonna like watch me noodle around Pinterest, and if we see something that excites us or that we want to like mimic or imitate, we can maybe play around with that. It also, I mean, this is like, I don't know, in a way it's like a little bit embarrassing to like show, you know, how basic my like inspirational strategies are, just to like, you know, flip through shit that other people has made that looks cool and like, you know, rely on the algorithm to show me. But in a way, you know, I think there's something very real about that, and we shouldn't pretend that like inspiration just comes out of nowhere. The other thing is that like what's really funny is that for whatever reason, one of my best friends, Sebastian, who I went to high school and college with, for whatever reason, we like spent a ton of time together. And, you know, we were roommates in college and all this stuff. And somehow Pinterest always shows me his sketches. So like, this is a Sebastian sketch, this is a Sebastian sketch. And he always works like primarily by hand. And yeah, this is one of his. And somehow we spent enough time together and have enough similar interests, and, you know, kind of like the same aesthetic characteristics that like it's radiated all the way through to Pinterest being able to like recognize that we're similar and show me all of his shit. So yeah, there's another one of his. And in fact, he and I have also like collaborated sometimes where like he'll draw something manually and then I'll try and like reproduce it parametrically, and then we'll like hand it back and forth. As you can see, a lot of this stuff is sort of like architectural and spatial, and a lot of like either like axonometrics or like sort of extreme perspectives. I'm always really into playing around with stuff like that. I really like stuff that kind of like operates on the kind of edge between like legibly architectural and sort of like abstract and confusing. So a lot of stuff like this is always really interesting to me. So, you know, a lot of my work starts as kind of strictly 2D, and a lot of it starts 3D and then becomes 2D in a sort of architectural way of working. So I have not yet decided which of those things we will try to do. So yeah, let's see, what should we mimic? Let's pick something. I'm gonna do like a quick one as just a warm-up, and maybe it'll take us somewhere and maybe it won't, but just to kind of like get going and get past the scrolling, I might, just for shits and giggles, I might grab one of Sebastian's, since I was talking about him and giving him a shout out. And maybe I'll see if I can like reverse engineer it just for fun. This is a good one. I like this one. So this one has this kind of like 2D, 3D oscillating reading. There's some kind of like a random three-dimensionalized linear structure in the background, and then there's some other kind of thing obscuring it. So let's play around with that. I'm going to start with the background. I'm going to start with this like chaotic 3D network of sort of like angular connections that look to me like they've been sort of, they're at least ribbons. In fact, to me, they read as 2D ribbons. I might play, but they have, because they have this line running through the middle, they also oscillate in the reading as though it's sort of like it looks like it could be like a 3D form. He doesn't put a lot of his work online, but if you go to, I'll post a link here, innocentbydesign.tumblr.com. This is his old Tumblr, which I don't think he's updated in like forever, but he's super talented and you should check out his work. He's currently an interior designer at Gensler, or interior architect, and he's incredibly talented. And yeah, I don't know where the like archive of his work is, but yeah, always cool stuff. So let's jump in. Let us start making some kind of like random angular tubes. And I'm going to turn off this gradient view, and I'm going to hide all this stuff. So the way that I might approach this, I usually like to start with like a set of random 3D points. Populate 3D is really good for that. Here's my like random set of points. What I want to do is kind of like randomly assemble these into some kind of like line work that's connecting them. But I don't want to like interconnect all the points. I just kind of want to like set random sets together. So one way to do this would be to simply like partition it into lists. So I could say partition into sets of 3 and then make polylines out of that. Let's see what we get if we do that. So if I do that, I basically am extracting sets of 3 points at a time. The sort of data tree, this partition list will take the total list of, however many points and split it into lists of 3. And then I'm going to connect each of those lists of 3 together into some kind of little polyline. I'm going to turn off preview on this guy. So that looks kind of cool. I'm getting some of that kind of like angular character. And then, one of the things that like the reference drawing does is that it has these it kind of flattens these or extrudes them out into ribbons that sort of have some 3D characteristics. So we could play with that. We could use a random vector that would extrude that along some arbitrary plane, or I can use the plane that is described by each of these. Also, I don't like that Populate 3D uses like such a flat box to start with. Let's create just like an evenly sized box that I'll just give this some sort of arbitrary size. This shouldn't affect too much right now. So now we've got some interesting geometry. If I wanted to get a plane through all of those points, the simplest would be just like a fit plane. There are probably 100 ways to do this, but this way I get a plane from each. I can deconstruct the plane and then grab a normal, and we'll try that as the extrusion vector. I'm not totally sure how that will look, but if we took the plane normal and extruded each one of these along it, what do we get? We get something like this. We're probably going to want that to be a little longer. I'm going to insert an amplitude, although we could multiply it as well. Let's try and plug this in. And I kind of like the idea that maybe there's some random variation in the length of this extrusion. This is looking pretty good to me because you do get a kind of like variance in the angles and the depth of stuff, but maybe it would be fun to like to use a random amplitude. I often will introduce sort of like limited degrees of randomness when I'm making work like this, and it's just kind of a fun way to go. So let us take, let's create a list of random numbers. So oftentimes what I do when I have a data tree like this and I want to create random numbers, a trick that I often use is I'll take the list length and flatten it. You'll often hear me say when I'm teaching Grasshopper to never flatten, like flattening is the devil, and I really believe that, but there are a few cases where it's acceptable. The reason I say that is because flattening is an inherently destructive operation in your data tree. And if we decided that we wanted to make 2 of these by supplying like 2 different boxes and, you know, doing something upstream, if we flattened, now the logic is all broken. But in this case, it doesn't particularly matter. And what I'm going to do after I flatten is unflatten. So this is a pattern I like to use. I'm going to say, okay, how many of these things are there? And I could have used any one of these lists because they all have the same list length. And I'm going to create n random numbers, and then I'm going to use unflatten in order to basically take that geometry back to its source tree. And, you know, maybe I'll use this little fun guy so that this is a nice and clean little routine. So now I have a kind of matching set of random values. And actually, you know what? I was wrong. I don't want 100. I want the number of planes that we got, because I have now how many extrusions? I've got 34 of them, so I really want 34 random amplitudes. So I'm going to take these values. I usually don't supply a range into random upstream, just in case I want to like tweak the values. You'll find me using the remap number component all the time. It's one of my favorites. And this way I can just sort of set an arbitrary domain. And usually what I do when I'm about to replace a static number with a set of random numbers is first I'll set the domain to be from that number to that number. So basically a 0 length domain, so that and it's a good test. If, when I replace this, nothing changes, I haven't broken anything, but now I can see that if I want to introduce a few fatter ones or a few narrower ones, I have that option. So, I don't know. I kind of like that they're all roughly the same, but let's just go with that. And then, in order to also introduce the kind of midline, because if we look at the reference drawing I'm copying, there's this kind of like central line that he's got that sort of is parallel to the edge and not quite centered. And in fact, in some cases, it looks like there's 2, and in some cases there's 1, and in some cases they don't even run perfectly parallel. But for now, let's see, how do we want to do this? What I would say is, let's let it be, I'm having fun with this. Let's let it be a random number of these kind of central lines that follow along this guy. Also, something I often do, I have my shaded viewport set with a default background color of white, and I like to view stuff as close to the way it's going to look as a drawing, like right away, so that I get a sense for kind of the aesthetic characteristic I'm getting. And so, and in particular, I like to view things as opaque so that I get all of the benefits of occlusion and stuff. So I'm just going to do a custom preview for now. Let's just go like this. We'll do, this is a little MetaHopper trick. If you have MetaHopper installed, you can type COL equals and then the name of a color, and it'll pre-populate a swatch. So you can do col equals red and get a swatch pre-populated with red. So I'm going to use that. I'm going to leave the fact that it's shaded for now. We could also, if we wanted it to be totally flat shaded, we could render it as a mesh and use mesh colors, but let's just leave it as this for now. And then the other thing we'll do is we'll extract the brep edges, and we're going to custom preview those. Yeah, see, this is already looking better. We'll do a custom preview with COL equals black. And yeah, that looks pretty cool. What I was saying before, if I really wanted, I could do mesh colors instead of custom preview in this particular case. And use, actually, let's just do that and turn that off. And then I don't even get the shading at all. And just for those who don't know my work as much, especially over the last, really maybe almost a year and a half or 2 years, I've been mostly producing my drawings with an Axedraw, which, hold on one second, maybe I can actually show you my setup over here. So it's probably a little hard to see, but can I make this a little bigger? Hold on. I'm new to all this live streaming tech, so in any case, this is my Axedraw. It's a little CNC machine that holds a pen, and then I basically mount some paper, and I can drive it using, I use Inkscape, which has kind of built-in tools for driving the axe draw. There's like an axe draw plugin for Inkscape, but you can drive it any number of ways. At one point, I even tried to write a Grasshopper plugin that would drive it, but it wound up being more trouble than it was worth. So in any case, the reason I show you that is just to emphasize that, like, the reason I like to visualize everything as close as possible to sort of like pure black line work on white is because that's actually how it's going to look at the end. Although, you know, sometimes I'll play around with shading too and then figure out some mechanism to like translate that shading into line work at some later point. So that's looking pretty good. So we said we were going to try and grab some random lines along these. And I think what I want to do is first establish how many lines I want for each one of these extrusion objects. So I've got 34 extrusions, and I want to create a random list of numbers, or like a random count for each one. So again, I'm going to use this pattern. And in fact, I use this so often, I'll often just cluster it. So let's put this here. So I'm getting the list length, and I'm getting now a new list of random numbers. I should have exposed that seed. So I will just put a seed input there. And that way now I can get different random numbers. Because one of the things that happens if you start using random over and over again is that if you use the same random seed for all of the randoms that you generate, you get all kinds of weird things. In fact, actually, hold on. This is like a total diversion, but we're having fun. So I'm going to show you something weird about random in Grasshopper and the random generator that Grasshopper uses, which is, I believe, just system random. So imagine we wanted to create some random 3D points. Don't worry, I'll come back to the original definition. If you grab random, and let's just create like, let's create 100 values, and let's give them 3 different seeds. So I'm gonna do, let's just do a series with a count of 3, and we're gonna, actually, I don't think we need to graft it because it'll put these as as branches automatically. And then what I'll do is I'll just say bang to get those 3 branches, right click, match outputs, and then I'm going to construct some XYZ points. So in theory, I hope I'll be able to demonstrate this because it's super weird and it's driven me crazy forever. Let's do this with actually like closer to 1,000 points. So I've got 3 different seeds. Looks like I've got a random set of numbers, right? Or a random set of points, I mean. What you'll see, yes, oh perfect, it did it. If you rotate around, these are not as random as they look, even though I'm providing like different seeds. And the thing is that this phenomenon will occur regardless of like how you structure your seeds or whatever else. Like there's something about the algorithm that generates these random numbers that has some predictability, and I like probably someone on the video can explain a little more like why this is happening. But in theory, if I'm supplying 3 different seeds and getting 3 different sets of random numbers, I would expect them to be sort of like evenly distributed, and yet somehow it creates these sort of like funny alignments between the random, which drive me absolutely insane. If someone knows how to like fix this, but it honestly, as far as I know, it like really doesn't matter what you do. Like I've tried multiplying by like arbitrary like decimals and stuff, and like nothing that I do to the seed can prevent this from happening in some way, shape, or form. So actually, that seems to have done it, but I suspect that under other circumstances, this will demonstrate those same alignments. It's just like maybe less legible in this particular fashion, because sometimes it produces like, yeah, you can see that like sometimes it works, and there are other kinds of these alignments that I've perceived in the past. I do not understand why this happens. It drives me totally insane. But it's just something to keep in mind when, as we go back here, you're thinking about having multiple seeds for stuff. Oftentimes, in what's really more of a superstition than any kind of fundamental understanding of what the fuck is going on here, pardon my French, is that I'll just put like, you know, a super random number with some random decimals in it. Oh, that didn't work very well, did it? Let's try 45 point. I know that it ultimately rounds it to an integer anyway, so the decimals are probably, again, like totally meaningless. But I want to avoid these moments where there's some fundamental correlation between the random values in one property and the random values in another. Okay, those are crazy aside. So I've got a list of random numbers. I'm going to want to remap these, and I want there to be, remember that the value that I'm generating is the number of stripes, the number of like internal lines on each one of these extrusion objects. And I think what I'm going to do is set that to be somewhere between 0 and maybe 3 at the max. So what we'll do is I'll say, let's just construct a domain so we can play with it between 0 and 3. Maybe actually, sometimes I'll do this. I'll go one larger than I want and then just use the floor once we do the random, because this is going to give me decimal values, but if I round it using the floor, we'll get a list of these values. And so sometimes we're going to get 0, sometimes we're going to get 2, sometimes we're going to get 3. And that's going to be how many stripes to make. So now, how are we going to generate the location of those stripes? So my plan is already that what I want to do is use the fact that these extrusions each create UV complete surfaces and then grab isocurves along them in order to get these edges that are going to be sort of parallel to the sides. So let's just set that up first, and then we'll bridge the gap. So if I, let's see, so I'm going to explode the B-rep, and that's going to give me the individual surfaces, and then I'm going to use isocurve on those surfaces. And for now, let's just use a single value. And what I always do when I'm grabbing an isocurve, because I can never remember which side is going to be the U and which side is going to be the V, I just supply a point that's at, that same coordinate for U and for V, and I plug that in. And let's reparameterize just so we know where we're at. And then I inevitably just attach a domain to figure out, okay, it was the V curve and not the U curve. So now I can grab that, I can turn this off. Now these have the kind of middle stripe, which looks pretty cool. But I would like now to be able to generate sort of random middle stripes, and sometimes none at all. So let's take this, which is going to be the count of random stripes. Also important to note that as we look at the data tree here, because I've exploded this B-rep, which was basically, or this list of B-reps, which was a grafted list with 34 branches. Now I've exploded and I've got 34 branches, which may have 2 items. And so what I don't want is for the stripe to be in one place on one of the faces, and then the stripe in a different place once it wraps the corner. I want it to be continuous, so I want to make sure I supply the same sampling point for each list of surfaces. And I believe I'm in a good shape to do that because I'm generating one value per original B-rep. So let's see. The other thing I'm going to do is I'm going to save this, because I always run into trouble when I get really far down in something, and because I've never saved it, then I don't get the benefit of autosave. So I always just make sure I save in case I do something really stupid, or accidentally multiply 10,000 numbers by 10,000 other numbers in some kind of a cross product scenario, and then everything just explodes. Okay, so now these are generating our counts. I believe what I want now is again, some random numbers, because I'm going to want random numbers from 0 to 1, and this is going to define how many of those random numbers I get. So what are we going to do? We are going to, again, use a random component. This is going to tell me how many random numbers to get. And I believe if you supply a 0, I'm going to get an empty list. Yes, that's exactly what I would have expected and what I want. So we're not going to, some of these just won't have internal stripes at all. And so this is giving me the right number of these. Now, because these all have the same seed, we're in trouble. So what could we do? There are a few different ways to tackle this. One would be to generate a different seed for each of these. The other thing we could do is use a similar like unflattened tactic. Let's try this. I think what I'm gonna do, because if I make this the count, it should have the same behavior where if the count is 0, I get nothing. I get an empty list, right? I don't actually care about the values of this series. I'm just using it to sort of model the list shape for what I want. Now, what do I mean by that? If I take the mass addition, the sort of flattened mass addition or sum of all of these values, this is going to tell me how many random numbers do I need in total? 37, which makes sense because there are like a lot of zeros and maybe some ones and some twos. Now I'm going to generate a flat list of 37 numbers, which now these are all going to be different from each other. If I am correct, this series with structured values also has 37 values. And so now I can use unflatten to basically coerce this set of random values back to the structure of the random values that I wanted in the first place. I also just could have like kept the random I had here. Like all this is doing is providing a shape for the data, but I don't know, conceptually it feels weird to have a random set of numbers where I don't even care about the values. So now this should actually match our data tree. And similarly, if we plug this in, for those who don't know, one of my favorite Grasshopper keyboard shortcut key combination things is holding down Control-Shift in order to drag an entire bundle of wires. And now let's see what we got. It looks like, it seems maybe like it's working. I think we've got a lot of ones. I'd be curious to find one where we're getting 2 or 3 because I don't actually see that. And I'm not 100% sure everything I did is working. So just to make sure that things are working, I'll set the max here to be more like 10. So we get a few more ribbons with a few more stripes. Now it appears to be working. I'm getting like some variation in the number of internal lines that run parallel. Now I can also see that something else is wrong here because remember how I said for my ribbons, I wanted them to wrap. So this is not quite working. And what I suspect is happening, yes, of course. What is happening is we're running into everybody's favorite longest list matching problem, which is that I'm providing this list of points, one per ribbon, or one list per ribbon. And then I've got these, which are a list which have multiple like surfaces per ribbon. So this is a very common data structure issue, and you have to like move shit around. You have to basically like restructure your data such that we have this entire list for each of these. And there are a bunch of different ways to do this, but the way that I like to do it is with some MetaHopper components that I've built for kind of doing some tree and list manipulation. So what I'm going to do is I'm going to wrap this list. And what does it mean to wrap a list? I'm going to use wrap list and levels. Wrap list is very similar to group, but it takes a list of values like these and then turns that list into an object, a singular object. So an object with no items, an object with 2 items. Now I can use longest list, and I'm going to take my wrapped list and my list of surfaces, of which there may be 2, there are probably 2, and then I can unwrap the list that I wrapped and graft the list that I didn't wrap. So let's disconnect some stuff. So I'm going to graft this now, and because remember we've got those sort of like pairs of surfaces. Now we've got you can see the data structure there is like 0, 0, 33, 0, 0. So I would expect if I did everything right, that's exactly what I'm getting here too. So now with those unwrapped values, we've got a sort of perfect corner turning. And so every ribbon has a sort of like consistent pattern along that ribbon, which is cool. It adds to the like 3-dimensionality of this, and I kind of like it. I'm also kind of liking starting to deviate from our reference sketch and introduce like more parallel lines. I think this is looking kind of cool. I also like that there is some contrast going on between like the inner lines and the outer lines, and just to keep things black, I think what I'm going to do is do custom preview line weights. Plug these in, plug this in, and then let's make some fat lines for the outside. And in fact, let's only do that for the naked edges. And then, ooh, that's kind of cool too if we like skip the fold line. I'm not sure what the original, but it's nice when you see it there. So maybe I'll bring it back in. But what I'll do is I will bring it back in with a lower line weight. This is a component from Human, preview with line weights, that allows you to set the pixel width of stuff in your Rhino viewport. So let's use thin lines for the insides. And let's also include those inner edges in this sort of like lighter line weight. So that's looking pretty cool. I've definitely got some like other shit previewing that I don't particularly want. Oh, I did want that. So that's looking pretty good. This looks cool in and of itself. It's also like totally 3D. And so, you know, I could decide that it's much more interesting to view it from this angle or from this angle or whatever. And, you know, the other thing is that we can now start to like flex the box that we've got. You know, we can, if I make it bigger, it's probably not going to do a whole, yeah, that's doing something, not a whole lot. I mean, I would expect that Populate 3D is going to use a very similar logic independent of the scale of the box. So, but we could, you know, we could separate these out so that we're not necessarily working with like a perfect cube. Play around a little bit. Yeah, it looks cool. We could increase the number. Right now we have 100, which is going to get divided by 3 because we're partitioning by 3. We could also partition by something else and get more complex zigzags. Now each one of these zigzags actually spans, like each one of these ribbons spans 6 points. But you know, I kind of liked where it was at 3. 2 would be really boring, but 3 looks pretty cool. So, okay. Here's some stuff. Now what do we do? I think let's I kind of liked in the original the way there was just this like random figure which seems to have been sort of cut out of a rectangle with some voids and some like construction lines. And I kind of like that that's like obscuring everything that's beyond. So let's see what we can do about that. It definitely won't look exactly like this, but I think we can do some similar things. So what are we going to do? In order to create that figure, I'm going to create a rectangle, and I could do this randomly. For now, I think what I'm going to do is just like literally draw the rectangle, but later on we can maybe like couple this so that we can generate like hundreds of random variations of this drawing if we feel like it. But I think for now I'm just going to like make one. So let us specify one rectangle, which let's kind of do it like that. I don't know. And what we're going to do, it's also probably in the ground plane, so we'll move it up in the Z by a lot. I often render, like treat my drawings as like strict top view, and then I actually use like 3-dimensional layering to control like how they flatten on top of each other. There, I imagine at some point we're going to do a make 2D with this drawing. So let's just bring it up by 50. That ought to be sufficient. That looks good. And then what I want to do is create some shape out of this rectangle that carves it away. So if we look at this, there's like, there's kind of these lines, some of which like extend a little beyond. So I think this strategy of like starting with a limited set of random lines that lie across this surface would be a cool strategy. So I'm going to make a surface out of this guy. I'm going to do populate 2D this time. And that's probably well, actually, no, let's leave this. Let's do partition list by 2. This is going to be way too many lines, but we're going to reduce it later. So let's do a polyline to make those into my, you can see this like repeating pattern here where I'm generating random lines by generating random points and then partitioning it in order to construct these. So also, I'm going to, just so I can see what I'm doing, I'm going to turn off preview for this guy. So I now have a list of random lines that lie on that surface. And I might want to just, so remember before I was saying never flatten anything. In this case, I do care about that because what if I want to generate 2 of these? Whenever you think you should flatten, you should really p-shift or shift paths. This is a non-destructive way to basically like pop one layer back out of your data tree. So these are looking cool. I might also extend them a little bit. Also, like, the ordering of this really doesn't matter. Like, I could have done this before or after the P shift. I'm just kind of improvising here. Boop, boop. Extend them a little bit, and then I'm going to do a random reduce in order to get back, let's say, well, how many do we have? We've got 50. And I'm actually just going to say, I really only want, let's say, 10 lines. So I'm going to subtract 10. And we will say reduce by, because I think this is the amount that you reduce by, right? Yeah, number of items to remove. So now we should have, if I turn off preview, 10 random lines. That might not be enough. So let's try 15. You'll see that I also, like, I don't even edit sliders ever. If I need a new slider, I just type a number in the search keyword and replace the old one. So yeah, let's try that. Then we've got our rectangle, which is up here somewhere. I might, just to avoid things getting too tangled, I'm just going to shift all this shit down here. Let's extend a little more. I just want there to be, like, the possibility of this thing, like, splitting. Because let's see what happens. If I take these lines and I use surface split, this was my idea, was to basically take these random lines, split them. Component that I really love. Okay, so yeah, that actually looks pretty cool, and I think this is along the lines of what I wanted, which is, pardon me, that's a cough, by the way, for those of you worried about me, that's a cough that I've had for a very long time, and I feel fine, and I have had no fever, so please don't be concerned. When I do a surface split operation, I often want to see the like individual things and just make sure that the split happened correctly. It used to be that like split would fail a whole lot more and you really had to be careful about this, and it's gotten a lot better, but I'm still superstitious. So I use a component from Wombat called Identity Preview whenever I just want to make sure that items are distinct from each other, because what it does is it just takes your objects and colors them with a random color, so you can see that, like, yes, this object is distinct from this object. So also it looks kind of cool in and of itself. But that's a nice, like, just debug check, is to make sure that this split actually worked. And then what I want to do is, like, randomly remove some of the shards from this thing. And I think I want to, in order to kind of keep the spirit of this, I want to prioritize those. I want to prioritize removing the shards that are closest to the middle. So let's take this surface. Let's take its center, which we could do any number of ways. Let's take the center of all of these. You'll notice I'm pretty loose about data typing and just like casting shit willy-nilly because Grasshopper supports it so well. So even though this is a surface, I'm going to treat it as a polyline for the purposes of finding its vertex center. You know, I could have used evaluate surf or area centroid or whatever. That would have been fine too. So let us take the distance from the center of the rectangle to the center of all of the surfaces. And I think what I'm going to do is sort the list of these. So I'm sorting them by their distance. And then let's just look at what a sublist might look like. So if I take, how many of these do I have? We're looking at 51. So let's try 20. So these are the 20 that are closest to the middle. And actually what I want is to reverse this list so that I wind up with the ones that are outermost. So let's say, yeah, that's kind of what I'm hoping for. That looks cool. Let's go with that. So now I'm going to take all of these, turn them off. Now I've got my like shape that I'm going to want to be rendered in front of all of my line work over here. I'm missing some stuff. Oh, I'm missing my mesh. Where'd you go? Oh no, mesh is on. Preview. Oh, this preview line waits. Okay, and then this will also just mesh colors in order to represent it as white. COL equals white. Plug that in. And then what I want to do is bring back in those edges. And so what I could do is, I think what I'm going to do is actually join this back into some V-reps. Merge their faces. Maybe, maybe not. Yeah, let's do that. Let's merge their faces. We'll see how it looks. So basically, I'm going to remove all of the like internal edges that were there. But then, in order to get that kind of like construction line look, I'm going to actually get the edges back out. So I'm going to do, actually, let's use V-rep edges. Out of this. Let's take the naked edges and boop, boop, boop. Should I, how did it look in here? I think I'm just going to kind of extend them all. Let's see what happens. Whoops, extend, curve, naked edges by 4. Let's try that. Yes, custom preview line weights. We're going to do like 3 maybe, color equals black. If I could type, plug that in. Yeah. So it's looking, I kind of like that they're sort of construction liney, and then I might take the fragments, like I think what's cool about this, well, it looks like the whole border of these shapes does have sort of a thickened appearance. So if I wanted to do that, I would take the, just the original naked edges. Actually, I don't even need this copy. I can just take this and plug these in and make these guys a little fatter. And now we're getting somewhere. So that looks pretty cool. I'm into that. It's still pretty derivative of what Sebastian had done, so I don't know if he would be like cool with me like claiming this as mine, because it's like clearly a ripoff. And so oftentimes when I get to a point like this, I'm gonna start trying to like move away from the reference, because like I don't ever want the result of something where I was like deliberately imitating or mimicking to just look like a ripoff. I am certainly guilty of producing work that looks a hell of a lot like the thing I was referring back to. But I said this before, like, I think what is cool about doing this with Grasshopper is that, like, all I have to start doing is, like, tweaking the sliders and tweaking the logic in order to get something interesting. So what could we do here? In order to make this like a little more mine and a little less his, what could we do? One thing we could do is we could curve the ribbons rather than have them be sharp, although I do really like how sharp they are. Let's try it. Let's see how it looks. It's probably going to look like crap. If we wanted to do that, we would just take the polylines we generated back here and fillet them. Or, well, there are a few ways to do it. Let's try it with a fillet. I love a good fillet, let me tell you. Let's try that. It's already looking bad, but let's try it. Let's see what happens. You never know. If I plug that in, this might break some stuff. No, I don't know. Looks kind of cool. It's definitely different now. Also, you'll notice that our mesh technique is not as effective anymore, because if we turn on mesh edges, we're getting a very coarse mesh. So we're going to have to be a little bit more controlled about how we generate this mesh for the purposes of it being white. We could just turn this back on, which is kind of cool, maybe. I don't know. So, we could play with that. There's something kind of cool about these ribbons. We can play with the random range and maybe let them get a little fatter. I'm probably just making this worse. Like, I really can't improve on what Sebastian had. Let's see. What else should we do? What if I don't have this? Let's just look at where we're at. Whoops. This guy is also here. Yeah, I don't like that very much. Let's let it be angular again. What else could we do? Let me see. One thing we could do is actually like take the entire set of geometry and introduce some kind of like a distortion or a transformation to it. Sometimes that's fun. So, you know, sometimes what I'll do is, like, if I want to keep the fact that they're angular but introduce some degree of curvature into the system, I think what I'll do is, let's just try this manually first, and then we can always screw with it later. I'm going to make a surface over here. And we're going to make like a nice warped coordinate system. I don't know. That's ugly, but let's try it. And then we're going to do another one from here. So what if I were to take these, should I do it on the, let's try it just on the polylines because that's nice and easy. So if I take my reference surface over here and my target surface over here, then what we'll do is if I do map to surface, is it going to project everything back down? It might. Let's try it. Firstly, and let's just reparameterize these both so that they have the same domain. Are they still 3D? Yeah, they are. That's not bad. And so all I need to do now is, I think what I'll do is I'll explode them, and I'll rebuild them, and then I'll rejoin them. So let's rebuild with, like, I don't know, 10 control points, and then let's rejoin them. Yeah, that should work. And then, and whenever this is another like data tree point. Whenever I am stitching something back in, I'm gonna do a double check and make sure that basically, like, okay, here's the path that I have going into this guy now. And this is now different, can I get it back to where it was? And so in this case, this introduced a new layer. This did not introduce a layer. This introduced a layer, so I'm going to need to p-shift by 2 to get it back to where it was. And so now, are we getting any curvature from these? I can't tell. Or did my rebuild not work? Oh, because I meant number and degree is 3. There we go. Now we've got some curves. All right, let's see. Oh, another favorite trick that sometimes blows people's minds is the option drag, parting the Red Sea feature to make some room for yourself. So I'll plug this guy in. Let's take that. Let's plug that in. Let's see where we're at as the general drawing. That I like better than the fillet, that's for sure. There's something cool starting to happen here. I like that we're getting like a little more like curvature and dynamism out of this. I kind of think maybe one way to play with this would be, rather than to just obscure it with some geometry in the front, would be to like Boolean it out or trim out some geometry with some sort of a void, maybe. I'm not sure. Let's see. I do like where we're starting to get here, although I might tweak this guy a little bit more. There's something nice about that. Let me just rebuild you by like 5 so that I have a little more control. Ugh. Let's see. I don't know. Oh, forgot one. Yeah. I don't know that that's doing much that's interesting. Okay. Okay. Oh, I appreciate there are a lot of suggestions in here. Let's see. What should we do? I think I do want to like subtract something from this. I think I want there to be like a void. And so let's see what that could be. Also, this is nasty. Let's see if we can clean that up just a little. So, and also we're only seeing half. Yeah, some sort of a void I think would be an interesting thought. Yeah, let's try that. So, the original rectangle that I specified over here was somewhere else. Let's try like something like that. And let's see where we're at with that. I mean, I don't know, that's kind of cool. It's still a little too Sebastian, but I feel like there's something in this. I mean, I don't know, now I kind of like it. This is the problem. I stand there like looking at it and stuff. I wonder if maybe I think it would be a mistake to use the same map surface, but let's just try this. I think this is going to be a mistake, because I think having things flow too closely along. Oh, there's my text. Hello. Having things flow too closely along the same kind of like distorted coordinate system is probably not the way to go. But let's just try it. So these are my surfaces. This may or may not work if I just like cast them to curves and then cast them back again. We're going to want to do this in such a way that it's near the reference surface, so I'm going to have to draw it like here or something. And then let's take those and try mapping those and see what we get. Also, this is another case where, because they were sort of like polylines, in order to get like nice results, I mean, actually we could try it as is. Okay, we're going to do this and then this. Do a little surgery. But of course that is now going to be in the wrong place. So in fact, what we want are the undistorted ones for the purposes of the sort, but we only want to sort the distorted ones. So what do we wind up with there? Yeah, I don't like that too much. Is it possible that just like doing a different rectangle would be sufficient? Or maybe like a pair of rectangles? To kind of like take it along its flow here. This is one of the, now I'm going to be really glad that I didn't flatten anywhere. So I know I can do that effortlessly, because all it's going to do is add a little more variety there. And then we're also going to want like 2 different seeds probably for this. Graft. Okay, so if I have 2 different seeds, I'll get 2 different results. I kind of want... See, now I feel like I might want to bring back like properly circular geometry rather than this kind of like arbitrary bend I did. So what if we used an arc somewhere? Let's see, how could we do this? I mean, I could just model it. Let's do that to start. Center of arc from like here to here, and then we're gonna like offset it through point. This is probably too extreme. Let's do it anyway. Now, if I have that, and then I'm gonna want, because I want to refer to these. Oh, here's another little tip. If this is my like reference surface, oftentimes if I have stuff like jumping from parts of the definition to another, I'll use telepathy. So I'll say send equals reference surface, and send equals target surface. And then down here, I'm going to replace these with a receiver equals reference surface. And this will automatically wire itself up to that other thing. Or I can like right click and go grab it, target surface, and it will populate itself. So now I'm using the same thing in both places. This definitely feels like too much. It's just too like long in one axis, so maybe I can just like I can do like a subsurface, aka an isotrim, and I'll just set domain 2D. We're gonna do domain 2D, construct domain 2D from 2 numbers, from 4 numbers. Yeah, let's do that. Reparameterize, and then I'll just say like 0.5. We'll see, is it in the V that, yeah, that's kind of what I wanted. So I can like slide this thing along. And now the more that I look at this, the more that I think that these actually really do need to curve to sort of follow this like new geometry. So let's hide this and this. So in order to achieve that, it was this moment where I mapped the surface. Instead, what I should do is I should, just like I did before, I'm going to explode the curves. I'm going to rebuild them with a degree. I think it has 3 by default. No, it doesn't. We'll do 3, and we'll use 10. And then we're going to rejoin. And I believe I'll probably have to do a p-shift over 2 here to get back to the data structure I had here, which was 0, 1, 0, 0, 0. So yeah, let's try -2. 0, 1, 0, 0, 0. Now those will curve and sort of follow the geometry. I mean, now that's looking kind of cool. I just wish there was like a little more variety here. So it might just be a matter of like tweaking a few of the seeds. Also, I need to clean up my order. We're going to need to part the Red Sea again. And make it so that we don't have wires going back on themselves. Yeah, Brian Ringley always used to yell at me for my poorly organized definitions, but especially when I'm like working creatively, I gotta go at maximum speed, and like, I just don't have time to like clean stuff up while I'm going. It's like much more important to have the like that flow. Yeah, that looks all right. Let's go ahead and save this. This is looking cool. I just want, let's see. I'm not super satisfied with the figures in the front. I would like them to be a bit different. Here's where they actually are. And so we can actually see, here they are. We could have done this whole operation. In fact, let's do that, because I kind of like being able to. So what I'm going to do is I'm going to actually move this operation, which does the distortion, to after the subset, so I can get a preview of what it looks like pre-distortion. So I'm just going to rearrange some stuff. So that goes in there. Now we're back. But then I'm going to take. This is probably a pretty good representation. Yeah, that's what I wanted. And so now if I plug this in here instead, and let's find all of the places where this goes, and maybe I'll even unite them using the little relays, that's what they're called. Let's plug this guy in, and so now, yeah, now at least with this preview on, I can kind of like visualize what's happening. And I think, is it a matter of having less removed? That's kind of interesting. This is like getting somewhere, I think. I think I actually want to reduce the subdomain of this surface even further, because it's just still like a little too long. That's like getting somewhere for me. I kind of like where we're at. I do kind of want it to be like oriented like this. I always rotate shit arbitrarily, like over and over and over again. The other interesting feature that's happening here, which might be fun to play with, are the moments at which the ribbons intersect each other. So also, can I get away with less line work? Can I like, what would it look like if I didn't have this? Nah, the line work's nice. By itself, it's boring. If I just have the construction lines, yeah, well, we'll see. Okay, so let's leave it all in. I'm feeling good about it. However, I do think it might be fun to play with the moments of the kind of intersection, stuff like this. So if I have all of my surfaces over here, I want to intersect them all with each other. Yeah, this is feeling, this could be cool. So what we'll do is, what are we going to do? We've got 33 surfaces. I'm just going to, in anticipation of, well, I will do this anyway. I'm gonna give myself a little gap, although I don't know that I'm necessarily going to replace these. But we'll see. I think what I want to do is take these, and oh no, they're B-reps, aren't they? And what I want to do is intersect each one with each other one. So I am going to p-shift this. So now I have a flat list, and I'm going to use cross-reference in strict upper mode, I believe. Strict upper triangle, which will basically say if you're not familiar with this, it's useful to understand. Let's do like a character sequence just to visualize it. So we'll do character sequence and we'll use cross-reference. So what does cross-reference do, first of all? Cross-reference is a way of having kind of like multiplying one list by another. So basically, let's just do this with 5 values. It'll be easier to see. So this sequence is just A, B, C, D, E. Cross-reference will generate A, B, C, D, E, A, B, C, D, E, A, B, C, D, E in the A, and then it'll generate A, B, 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 C, 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 so that you basically get every possible combination of the two. So if I were to join these two together, I would get every possible 2-letter sequence you could make out of A's and B's. Now, if I switch to strict upper, well, here, let's cycle through the options. Diagonal will just be, actually, I don't even know what that does, honestly, but because I never use it. It describes it. Do not create those combinations where all items have the same index. I see. So this is everything minus the diagonal. So you won't get an AA or a BB, but you will get a BA, and you will get an AB. Upper triangle says, and if you visualize this as a matrix, where basically like your list is along the x-axis and along the y-axis, if you imagine the kind of like, every possible combination along that grid, and visualize just the upper triangle, you'll see what you get, which is like every pairing of the two, regardless of their order. Because when I do holistic, I'm gonna get an AC, and I'm also gonna get a CA. If we do upper triangle, then we'll get every possible combination where it doesn't matter. So if I have a DE, I will not have an ED. And upper strict removes the ones where they have the same index. So AA is not going to be here or BB. But this tells me that for these 5 options, there are basically 9 ways to combine them as a pair, irrespective of the order. So why do I care about that? When I'm doing an operation like this, where I basically want to have every B-rep intersected with every other B-rep. I may end up doing this and then wind up, for data reasons, going back to something a little bit more brute force, but I just want to demonstrate it. If I now say intersect every B-rep with every other B-rep, this only has to, there are 33 of them, and this only has to execute 528 times, but it's going to find every intersection moment between any two ribbons. So it is actually going to find any of these moments where the ribbons intersect. So this is like pretty useful. Now what I might want to do, I'm still like not totally clear what my hope is with this, is I might want to introduce like a reveal for one of the, like maybe one of them pulls away where it intersects another one. I feel like that could be cool. Let's see what happens. It might wind up being a little difficult, but let's try that, and then I might call this one done depending on where we land. So if I now have these, now I've got a bunch of these surfaces. What am I doing with them? I'm getting their edges, I'm converting them to mesh, I'm deconstructing them as individual surfaces, which should be fine, and then I'm getting isocurves. So I'm basically, the reason I'm doing this check is I just want to make sure that if I were to introduce a trim to these currently untrimmed surfaces, I wouldn't break anything. And in fact, I think I'm safe, because even isocurve, like if you have a surface that has some hole in it, like, I don't know, we'll just do like this. I believe if you take that surface and do isocurves from it at some coordinate, it is gonna respect the holes. I don't think it always did, but I remember I just did a tutorial the other day where I found out that it did. So is that true? Let's just see. Oh yeah. Yeah, see, it's actually trimming it against the trims, which is great. So I believe we are safe if we introduce a trim. So how are we going to introduce a trim? It's always hard to like Boolean an object in 3D that's not a closed volume. So let's see what we can do. One thing we could do is, I kind of like this idea. Let's try this. This is probably not the best way to go, but I'm going to do it anyway. So let's take these surfaces and in fact, let's So I think I have to get rid of this because I think I need to know which surface each edge belongs to, but that's okay. So I'm going to explode the B-reps with deconstruct B-rep. Now I've got all my whole surfaces. I'm going to get their dimensions. This is going to look like crazy for a moment. I'm going to get their dimensions, and I'm going to construct some plane surfaces, actually, which have the same dimensions as these. Why on earth would we want to do that? Because what I'm going to do is I'm going to take these surfaces now, and unfortunately I think I can't use my like super efficient logic here. I think what I have to do is I think I am going to actually intersect, well, actually, no, let's use these because we've already gone to the work of calculating where these intersection lines are, and basically I just want to attach these intersections back to the surfaces that they came from, or in a data structure, which there are lots of ways to do this, but I think the easiest way, the sort of cheating way, is going to be just to use a distance test. So I'm going to find the middle of each of these intersection curves. I'm going to do a surface closest point on my surfaces, and I'm going to find these. I think can be flattened, or at least I'm going to adhere to my own rules and p-shift them just for the hell of it. So now I've got a flat list of all the points which are in all of these intersection edges. I'm going to test each one to figure out, because this is going to put, or actually we probably need to graph this. If the distance from each of these surfaces to each of these lines is smaller than 0.01, some small threshold, you never want to check equal to 0. You always want to check like smaller than some value, because floating point math will often introduce like very small numerical errors. It's always a good idea to have a tolerance. So if that value is smaller than this one, we're going to dispatch out the edges. So I've got 65 edges, which I'm checking against all of my surfaces. There's probably a smarter data structure way to do this, but when in doubt, use a distance logic. So just to check, I now have one list for each of my grafted surfaces, each of which has 65 values, which are the 65 intersections that we found. So now I'm going to wind up with edges that are organized by the surfaces they belong to. This is not dissimilar from a technique from like taking a waffle grid and then like unfolding it out flat. You'll see what I mean in a second. So I've got all these curves, they lie on all of these surfaces, and I've generated new unrolled versions of these surfaces, which just for shits and giggles we can view on a grid using arranging grid from Wombat. This is just to visualize, so I'm going to flatten it. But you can see basically I've created this like set of these surfaces, which are sort of like unrolled versions of each of the ribbons. And what I'm going to do is take, and actually, you know what? I might just because if I let this, it's gonna do that. So let's just unflatten post. We're actually just for clarity's sake, I don't think spreading this out is actually necessary, but let's just double check because there used to be a bug in this, which is probably my own fault, that the grid arranging stuff in grid would actually like shift its order, but I would expect that like is the order the same? No, the order is the same. Okay, cool. So now I've got my unrolled surfaces and I've got my surfaces in space, and I'm going to do another remap curve, or map curve to surface. Whoops, not that guy. Map to surface, where these are my source surfaces, these are my curves. This is like a really silly way to do this, by the way. So if I've done my job right, it's going to put, and let's also, always a good idea to reparameterize whenever you're doing anything involving a surface domain. Maybe not necessary in this particular case, but doesn't seem to have changed anything. I believe, now why are they all showing up on the edges? I wouldn't expect that they would, because I believe, are there a lot that are falling directly along the edges? It doesn't look like it. So something I'm doing is wrong here. What I want to see is a bunch of like, diagonal slashes showing up along these guys. And I see some, but there are also like a ton that are right at the edges, and that doesn't seem right to me. Wonder why that is. Let's just do, I'm a paranoid reparameterizer. Let's check data structures. We've got, no? Yes, these need to be grafted. Both of them. And just to avoid any issues, I'm going to lock the solver before doing my double graft. There we go. That's what I wanted. Okay. Whew. I have coffee as well. Mine has whiskey in it. I highly recommend that on a day like today. Okay. So what have we done? We took all of these intersections out in space, and we unrolled all of the ribbons and mapped them back down to the ground. And then what I'm going to do is I'm going to do an offset polyline using Clipper to just create some nice kind of like thickened versions of these. Might be too much. No, that looks good. That's like a nice size for my little like reveals where these intersections happen. And then, if all goes according to plan, I should be able to, let us do this. We're gonna do a, how are we gonna do this? There are lots of, let's do a region difference for now. which is going to take my unrolled surfaces and my little slits that I want to cut out of them. Let's just check data structures. This is probably going to have to be grafted. This is, yeah, that should work. It's going to cut those holes out. Ah, yeah, that looks nice. We like this. This is exactly what we were going for. So now, the next trick, you know the other thing we could do? Nah, I think this is the way to go. I think what we want to do, if we're lucky, we can we could maybe copy the trims. Let's test that over here. This is a weird component, copy trim, which allows you to take the trim curves from one surface and map them to another. So if this is the target surface, again, I'm going to graft. And then let's just check our, now we're in funky data tree scenarios. 67 branches, and then let's graft and check. 67 branches, yeah, okay, cool, I buy it. It's still, we could be in dangerous territory here. Yeah, so almost, but that's promising actually. Like, it's not quite right, but it did, like, I just want to be able to, like, because ultimately what I want to do is basically copy these trims. I think in any scenario where there were multiple surfaces generated, yeah, that's what happened. Yeah, any scenario where there are multiples, where we got a full through cut, we're getting this funky situation, which makes sense. Yes. This is not going to work exactly. So instead, what we're going to do, yes, this is what we're going to do. Similar technique, but instead of relying on boundary surface, we're going to use split surface again, where we're going to take all of our unrolled surfaces and all of our little cuts. And, oh, this probably needs to be grafted. Whoops, grafted, not flattened. And now we're going to take, did we get everything? Yeah, that looks pretty good. Everything whose area is smaller than, actually, or larger than some threshold, which I don't really know what that'll be, but we probably got some things with big areas and some things with small areas. So let's say if it's larger than 10, we keep it. Okay, so now, so why did I do that? What I wanted was to get a representation of the, like, and actually maybe my threshold's too big. Let's see if we can, yeah, we'll get, there we go. That's probably good. I wanted to get a representation of these surfaces minus their, like, reveals in the exact same kind of UV domain as my unrolled surfaces, because now I can use my copy trim trick because, well, at least in theory, you know, we'll try it. I'm going to take this as my source, and then I'm going to graft my original surfaces way back here. If I've done my job right, and this is a great big if I now zoom in, there we go. Anywhere there's an intersection, I get a cute little reveal. Look how cool that is. This is a tactic that you can use to, like, make waffle models and stuff. It's like, you know, check all the intersections, flatten everything out, do all of your geometric operations in 2D, and then map it back up to 3D. I have an extra hard case because I'm dealing with, like, curved surfaces too. But I'm really into those little reveals. I think those look pretty cool. And now, look how far off we got. So now, I believe, let's just turn all this off. Okay. Because I don't like this. This looks fake to me. But if we use this, now it looks cool. I mean, aesthetically, I don't even know if I like it that much. I think it's a cool trick. Can you guys hear the fire alarm? I think my boyfriend's cooking. Oh well. Hopefully you can't hear it. And hopefully my apartment is not burning down. All right. Well, there we go. You know, the other thing that's kind of cool, I actually sort of like these like close-ups of this whole scenario in 3D. I don't know. At some point you just gotta call it. I might just take everything we've got here and do a yeah, those little slits, man, that was a hell of a lot of work for not a lot of aesthetic value, huh? Oh well. That's alright. It's a cool trick. Okay. So I'm thinking I might call it here. But I'd like to do a couple things in order to get this ready for production on my plotter. Oh, you know what else we'll do before we do that? I'm gonna save this. I'm gonna try to introduce a little bit more randomness. And so also let's just flex this, because it's always fun to like, actually it's better, you know what? The smaller I make it, the better it is. I think it has some of the character of the original. And you know what? It pains me because it just took so long, but I'm just gonna like totally bypass my little slits. I just don't think they add that much. Oh well, hopefully you learned something from that. Let us, let's take all of our geometry and, yes, okay, I know what we're gonna do. Okay, what I like to do before I do a make 2D is I'm gonna actually like group all of the kinds of stuff into branches, because when I make 2D in Grasshopper, I should, in theory, be able to match the results back to the kind of like source geometry I was dealing with. Pardon me, and that can be quite useful. So let's take one thing at a time. Let us take these edges. These are the naked edges. These are the sort of or lighter line weight edges are going in here, and then we've got a mesh. And in this case, I usually make 2D like surfaces better than meshes. It really depends, but it's probably a good thing. And then I'm gonna take the raw surfaces from here. I don't have like a super logical order here, and I've got these, which are my like construction lines, and then I've got, did I already get these? No, let's get the sort of like thick edges. Cool. Okay, now I just have 5 very neat branches. I'm going to make 2D, and I'm gonna use the top view. I'm gonna flatten this, which again violates my no flattening rule, but I will unflatten it after the fact. So we're gonna need to construct a view, and I think for now I'm just gonna use a named view. I can also construct one geometrically, but this is often the easiest way to go. We'll type named view and save as like top for make 2D. Oof. I'm running out of steam, so this will probably be the last thing we do. And so we'll say view from Rhino view, and the name is top for make 2D. Hopefully it found it. Yes, it did. That's the view. No clipping planes, no tangent edges, no tangent seams. Let's see what we get. I'm amazed that 30 people have stuck with me through this, by the way. That's kind of amazing. So we got a bunch of stuff. Now, hopefully the visible lines look a little bit more like our drawing. Oh, did I forget geometry or something? Because it looks like we're not obscuring anything. Oh, I did. I forgot these. So, didn't I thought I... Oh, you know why? Because they're curves, is that why? Yeah, they're curves. I need to cast them back to surfaces before I can pass them along. That is why. Let's do that, and let's rerun our magical make 2D. And actually, let's do a merge. Let's do a brep join and a merge faces so we don't get those internal edges. Yeah, that's more like it. Plug that in. Rerun. That's more like it. That looks cool. I think what I would like to do now is I want to figure out which branch this shit came from before. Here's another trick. I'm gonna use wrap again, and this time I'm just gonna use it to make a list of items, and then I'm gonna say random color. This is a wombat component that I think I already showed, and then I'm gonna graph that just so that I have like one color per branch, and then I can do something like just color code my results, custom preview, all my geometry color coded by branch. We're gonna zoom. The other trick I'll show you is that if you cluster a custom preview component and turn on preview contents, even in this mode where you have only draw preview geometry for selected objects, it'll still show with appropriate colors. I love that trick. Okay, so I know that I want certain branches to be a little bit thicker than others. And so this is actually going to be a post-process on the 2D geometry, because now we're all projected back, we're flat. So what I will do is this is going to tell me the index of the source object. And so I flattened here. If I use the indices component, list indices from Wombat, which is really just like a list length plus a series, and then I want to figure out which branch each one belongs to. So how am I going to do that? I have 1238, 1238, 547, right, which makes sense. One thing I could there are probably some objects that don't show up at all. So how am I going to figure out which index belongs to which group? I think what I will do is I'm going to unflatten my indices. So now at least I have like per branch, I have these indices. And then I should be able to, for each of these, say member index. Let's try that. So basically, these are going to be the indices of the source object. So this is a list of 547 things. This is sort of a parallel list of indices. I'm going to find out whether this index for each of these 1238 objects exists in any of these branches. So the set to operate on and the member to search for. This is going to be the set. I actually have 5 sets and 1 list of members. And I suspect in most cases, the index is going to be -1. Oh, actually, it doesn't even do that. It just gives me back no index. So here's what I'm going to do. I'm going to take the list length of this and turn it into a Boolean. So why am I doing that? I'm getting now a false for each item for each branch. So this is going to tell me false if it was in that branch and true if it was or false if it was not, true if it was. And now I can p-ship this. And now this is going to be structured exactly like my 5 branches. And I've got now a list of true false values that are parallel to my resulting curves. So now what I can do, all of that messy kind of data tree stuff that I just did, what that allows me to do is dispatch my list, my flat list of make2D curves back into branches that correspond to their source geometry. So woof, that's like a big mess. But the beauty of it is now I can just double check that I got that right. And lo and behold, that make 2D sure looks like it got the source objects correct relative to where we came from. So let me go over that again, because this is like trying to match your source objects to like a particular branch after a make 2D is like definitely a useful trick, and this general pattern comes in handy a lot. So I've got some flat list of stuff. In this case, I've got 1238, and that flat list was generated from this other flat list, which has 547 items, which came from a non-flat list, which had 5 branches. I'm gonna get the flat list of indices from 0 to 546. I'm going to unflatten those to coerce those indices back into the branch structure it came from. So this is a really, it's going to be pretty straightforward. It'll be 0 to whatever. You know what I could have done too? I could have probably like created a domain from each of these and done a domain includes. That would have been, let's do that too, just for shits and giggles. I just thought of a better way to do this. If we take the bounds of this list, we'll get a domain, an index domain for each branch, and then we can do domain includes, where I've got my 5 domains for my 5, or my 6 domains for my 6 branches. I've got my indices, and then this is actually should be equivalent to what I got here, which is it'll be true if it's included and false if it's not. So in theory, let's actually just visualize this. Zoom. If I make this my dispatch list, that's way better. And this will be faster too, because now I don't have to search for every item in every index. Instead, I've just created like a range. So basically, like, because I know that these are gonna flatten out to a nice list of indices. And I know that it's going to go, okay, 0, 1, 2, 3, blah, 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 up until the end of that branch, 197. And then it's going to start over for the next branch, but it's just going to go sequentially. So I can safely say that if I just find the bounds of each one of those branches, it's like indices 0 to 197 belong to branch 0. Indices 198 to 440 belong to branch 1. Indices, et cetera, et cetera. And so by doing that, I can now take this list of indices that came back out, which are a map from my produced objects, my 1238 produced objects, and the 547 objects from which they came, in order to split this back out into a group according to the branch that it came from. So, there's a heck of a lot of work. What are we going to do with it? What we're going to do is we are going to bang, which is explode tree, so that we get these back out. And I'm going to take the curves that I want to be thicker, because I'm lazy when I produce my my drawings. I don't like to switch pens. Instead, what I like to do is I like to double up lines that I want to be thicker. So I want to take this whole set of curves, and I want these to be just a little thicker than the rest to have a little bit of line weight variation. And I might end up doing that with some of these others. These definitely want to be thin. These might want to be thick. These might want to be a little bit thick. And then I think these, the ones I just had, want to be the thickest. So, and then everything else can be thin. So let's take all of the, let's organize this. So these are going to be thin, 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 and thin. These are going to be medium. And these are going to be thick. So the way that I do this with a single pen, which happens to be 0.25 millimeters, is I just offset and double up the line and have it draw twice so that we wind up with a kind of double line. So what we're going to do is, these are fine. These I'm going to offset by some amount. And I don't really know what unit system I'm in now. So this would maybe be a good time to actually locate this on a page and know physically how big it's going to be so that I can make decisions about its line weight. So I have some snippets, some MetaHopper snippets that I use to sort of finalize every drawing that I do. So I'm going to do fit on page. This one's actually just a cluster. And all it does is it takes the bounding box of all my geometry and fits it neatly onto some predetermined rectangle, which happens to be the size of the paper that I use. So I'm going to take all my geometry and say fit on page. And now it's on the page in that geometry. And I might, just to get this to fit a little bigger on the page, I might just rotate it, similar to the way I had rotated my view before. So yeah, actually that's pretty good as is. I kind of like that. Let's go with that. Let's let it be a little dynamic. And then, so now my geometry is guaranteed to fit on the page and within the range that my Axedraw can draw. And this preserves data trees. Any cluster should preserve data trees, and that's a good reason never to flatten, especially inside a cluster. But that means I can guarantee that I'm still going to get my thin lines, my medium lines, my thick lines. The other cluster or snippet that I use for this process is Rapidograph pen preview. So I have a set of Rapidograph pens that have certain thicknesses. In the end, I almost always use the 0.25 one, but this will allow me to preview using custom preview line weights with their actual thickness. And when you turn on absolute in preview line weights, you can, it will actually scale the lines so that they take up the real dimensional space that they would. So this is really good for doing things like print preview. So I can see that I get, and actually now I'm going to have to turn off preview for everything. Nice thin lines. Now, let's make sure we do that for the fins. And then if I wanted to swap a pen, I could say, let's do this with a medium, and let's do these with a thick. But I'm actually not going to do this because I'm too lazy, although that looks pretty cool, but I'm too lazy to swap out pens. So instead, I'm just going to double up my lines, like I said before. So we're going to post-process these at paper scale. So what I will do is offset each of these curves by some amount. And let's make it 0.01 and maybe, well, let's start with the actual, well, what units am I in first of all? So this is this is gonna be really small. So 0.005, I don't know. I just guess and then I make it smaller or bigger as necessary. So let's look at these together. Yeah, there we go. See how I can just like give this the appearance of a fatter line by doubling it up? And we can validate that too by plugging all of this in with the same custom preview. I can now see, yeah, that'll just, I could go really extreme and then you actually start to see the gap, but I'm just gonna make it kind of like that. And then I'm gonna do the same thing with my thick lines. And I'm going to plug those in as well as the offset versions thereof. And these I'm going to permit to be a little fatter still. I kind of like that. I think that looks cool. Woof, okay. I think we're there. I think this whole set of geometry is basically ready for prime time. And so what I'm going to do is, there are two ways to do this. A lot of my work only generates polylines, in which case I can use a custom SVG exporter that I've written that actually has in it the like Inkscape template and stuff, so things come out grouped nicely. I can assign them layers and other stuff if I want to do like multi-pass drawings or whatever. But for this, I think all I'm going to do is bake it. Make sure I have preview turned off. I'm gonna, whoops, I didn't mean to do that. I'm gonna select this geometry, export it, and we're gonna make it an SVG and say live stream drawing. And let's do, it doesn't, now all my scale stuff is thrown off, but I kind of roughly know how to scale it, so it'll be fine. And there we go. The next thing I need to do is actually like prep it for Axedraw. I'm probably not going to do that on the live stream. I really wanted to focus on like the Grasshopper stuff. But this has been really fun for me. I hope it's been fun for you. Thank you for sticking with us for almost 2 hours, and 25 of you too. I'm really pleased by that. So I'm gonna stick around here for a minute in case there are more like just general questions or thoughts, anything you want me to go over again, just like random shit on the top of your head and you'd like to know how I'd approach it or whatever. But then we'll wrap up in the next like 15 minutes or so. I'm gonna take a whiskey coffee break. It's been my pleasure. Thank you guys all for joining. I hope it was a fun way to pass a little bit of time from the comfort of your social isolation. I hope to do these again. I think they're really fun. I'll definitely be posting on Twitter and self-exploding cluster. Yes. Okay, good. I'm glad someone asked that. So one of my favorite MetaHopper tricks is the snippet. So sometimes it makes sense to cluster something, but sometimes you really want to be able to expose like all of its controls, and there's no way to I wouldn't want to have to like type this in or whatever. I want to just be able to pick it from among a list. So what MetaHopper lets you do is take some set of components. So let's find actually like a good example of this. We can let's see. I'll just do a dummy example for now because I'm like out of ideas. But if I take some set of components like this one, this is a good one. This one generates like random points and random lines. So I'm gonna put these up here. I can say MetaHopper save snippet, and it'll take the stuff that's selected here and make it into a special cluster. So I'll say this is like random polyline. Okay, and now if I instantiate random polyline, it'll just give me back those components. And the way that this works, I'll let you in on a secret since you've stuck around all the way to the end. The way that this works, if you lock the solver and instantiate that same thing, random polyline, I would probably do this totally differently now if I had to. It actually creates a C# script that is responsible, that encodes within it a binary representation of all of the components that you set. So this is like really long. And then this script is responsible for instantiating all of those objects and deleting itself. So that's why if you do it when the solver is locked, it doesn't do anything. And then as soon as you permit it to compute, it creates the stuff and deletes itself. There's probably a better way to do that. I know a lot more about like programmatically instantiating components now than I did before. That's just like a fun trick and one that I use a lot. There was a question about whether my custom components are available for public use. A lot of the custom stuff that I showed belongs in plugins that are public. Like I showed a lot of human and MetaHopper stuff. Those are all public, of course. My like fit to page and stuff, I would be happy to share. They're just user objects. So if you're interested, let me know. I can share it. I haven't published them. I have a library called Sketch Tools that I deliberately avoided showing today because I knew the question would come up, which is like my personal plugin for my own use, and that I won't share because it actually like involves some of my like custom algorithms for doing like stuff that I consider like my style, and so I wouldn't necessarily want to make it available to everyone. So there's always like a trade-off, but if there are like specific user objects or clusters that I showed today that you would be interested in getting a hold of, just let me know and I'm probably happy to share it. Yeah.
I would definitely love to do a live stream of the floor plan stuff. I should do that. That would be really fun. The basic principle. I wonder if I even have it on here. Yeah, I think I do. This might like crash everything, so I probably shouldn't even open it, but I'm going to anyway. The basic principle. Oh yeah, it's mad. Why is it mad? Some serialization error. This is probably. I don't know. In any case, the basic idea is that I took a bunch of CAD files that come with the book 20th century, like great 20th century buildings, and programmatically read them, and actually like read all of the CAD and load it into Rhino, and then layer them on top of each other and do a bunch of like geometric processing to sort of like blend them together. So I won't reproduce those exactly, but I would love to do a live stream maybe next time on like working with source geometry, like for example, like my example CAD drawings or something. We'll close out of this guy. Well, I think I'll probably end the stream here. Thanks again to everyone who stuck around, and it's a cliche. You can like and subscribe on YouTube, and hopefully you'll get some sort of notification next time I'm gonna schedule something like this. I'll also be posting about it on Twitter and all the normal channels. And yeah, hopefully I can do another one of these soon. So, thanks.